Hi everyone, we're back with another video today. This is 9701, paper 13, May June 2023. This is actually our first video of 2024, so hoping this year goes well. Last year was actually amazing. Thank you for all your support. Looking forward to more this year, and hopefully this year I can release more papers. I will have a less busy schedule after April. I'll also be graduating this year from med school, so let's see what we can do. I also plan to hire a few more people to do more videos for O levels and stuff, so let's see where that goes. So currently my plan is to release more papers for the October November 2023 series right after it comes out on January 11th. So without further ado, let's begin, and let's take a look at the threshold first. So this is paper 13. So the full mark is 40. A is at 28, B 26, C 22, D at 18, and E at 13. Okay, so let's write that down here. The full mark is 40. A is at 28, B is at 26, C is at 22, D at 18, and E at 13. So A star should be somewhere around, look at the gap, it's like 4 or 2 marks, so maybe around 31. A star is probably at around 31 for this paper. So yeah, that difficulty was just like the other papers really. It just seems that maybe, paper 1, 2 was a bit harder than these because B was at a lower mark. So let's see, let's do this. I'll obviously link the papers, link the other papers. I've already solved them in my other videos at the end of the video. So I think let's begin. Also guys, if you do like the content, please do like the video and consider subscribing to the channel so that you don't miss any of these. Also, if you guys want, you can support me on Patreon. It's patreon.com/CAI papersolved, where there are 3 tiers, one for support, another one for access to all my solved papers for physics, chemistry, math, and bio, along with A2 and AS physics and chemistry notes for all topics, as well as help with solving question papers over text. And for the highest tier, you also get access to video meetings once or twice a month with me, where we can solve your personalized problems, right? Anyway, let's start. Starting with question number 1. Let's see. So, propanoic acid is treated with reagent X at room temperature. The organic product of the reaction is sodium propanoate. No gas is produced during the reaction. What could be reagent X? Okay, so propanoic acid is treated with reagent X. Now, the organic product of this reaction is sodium propanoate. No gas is produced during the reaction. Fine. So let's go through this. Let's take a look at A. So sodium bicarbonate or sodium hydrogen carbonate. If it reacts with propanoic acid, CH3, CH2, COOH, if it reacts with this NaHCO3, what actually happens? We are basically going to get carbon dioxide gas. Okay? So since they said that no gas is produced, this can't be the answer. Typically what happens when a carbonate reacts with acid, we get the salt, which will be sodium ethanoate, and carbon dioxide and water. You don't need the reaction particularly for bicarbonate, but it's similar. You do get carbon dioxide, so A can't be the answer, and similarly C can't be the answer either. Now what about NaOH? If you reacted with NaOH, what are you gonna get? You're going to get CH3, CH2, COO minus, Na plus, sodium ethanoate, and one molecule of water, but no gas. That is why B is the answer. Okay? And propanoic acid actually won't react with sodium sulfate. There will be no reaction. Now, the ionic equation shows iodide ions reacting with manganite ions in acidic solution. The letters U, V, W, X, Y, and Z all represent whole numbers. 2 or more of U, V, W, X, Y, and Z are the same as each other. Okay, what is the lowest possible value of V? So to do this, you basically have to use oxidation numbers. So for permanganate, you know that manganese has an oxidation number of +7 and manganese over here is +2. On the other hand, iodide is -1 over here and it turns into 0 over here. Okay. So as you can see, this is the math. So 5 electrons are transferred over here and only 1 electron is transferred over here. So to balance things out, um, we basically need to multiply this with 5 because 5 times 1 is 5. So it balances out. So W should be 5 times U. W should be 5 times U. So since we are looking for the lowest value of V, let's try this. So according to me, for example, if U is 1, W has to be 5. Okay? If U is 1, W has to be 5. Now the issue with this is basically Z multiplied by I2 will actually give us double the number, right? So this actually has to be 2.5 to balance things out because 2.5 times 2 is 5. But they said that all of these are whole numbers. So this can't be 2.5. So rather we need to multiply the whole thing by 2 now. So 2.5 times 2 is 5. 5 times 2 is 10 and 1 times 2 is 2. So U is 2, W is 10 and Z is 5. So X should also be 2 because X and U should match. And what about Y? Let's try to see Y. So I'm gonna balance oxygen first. 2 times 4 is 8. I have 8 oxygen on the left hand side. So I also need 8 oxygen on the right. So Y should be 8. And now if you look at H, 8 times 2 is 16. So I need 16 H plus. I need 16 H plus. So the only possible answer of V is 16. So you will find this particular equation many times because permanganate can also oxidize Fe2 plus to Fe3 plus. So the same balancing is also present over there. Okay. Next. A piece of rock has mass 2 grams. It contains calcium carbonate but no other basic substances. It neutralizes exactly 36 cm cube of 0.5 mol per dm cube hydrochloric acid. What is the percentage by mass of calcium carbonate in the 2-gram piece of rock? Okay. Neutralizes exactly this. Okay. So calcium carbonate reacts with HCl to form CaCl2, carbon dioxide and H2O. So to balance this, we need a 2 over here. Now let's find out the moles of HCl, yeah? What should it be? Moles equals to volume into concentration. So 36 by 1000 times 0.5. Do the math. 36 by 1000 times 0.5. That gives you a value of 0.018 moles. So the moles of calcium carbonate will be half of this, which is 0.009. Okay. Now we have the moles of calcium carbonate. Now let's find out the mass. How? So I have access to the periodic table over here. Although I know it's 100.1, I think. I have it memorized for calcium carbonate. This is also the last year I'm teaching, by the way. Like privately, I teach as a tutor here in Bangladesh. I'm from Bangladesh, by the way. So since I'm graduating med school soon, I am actually going to leave teaching because it's really hard to balance two lives at the same time, you know? Like teaching as well as studying for med school and being a doctor. It's just too hard. So I've chosen my path, my career path. So I'll be quitting afterwards. But not this channel though. This channel will continue. So don't worry about that. Anyway, so the help would highly be appreciated, you know? So calcium carbonate is 40.1 plus 12 plus 16 times 3, which is 100.1. So let's find out the mass of CaCO3 is going to be 0.009 times 100.1. 100.1. So that gives us a value of 0.9009 grams. So let's do the percentage now. So 0.9009 divided by 2 times 100 divided by 2 times 100, that gives you a value of 45%. 45.0%. So our answer is B. Yes. Next, 4. L and M are elements in period 3 of the periodic table. Neither element is argon. Information about the Pauling electronegative values of L and M are given. So highest of the 7 elements and the lowest of the 7 elements, Na2Cl. So check this out, guys. Check this out. How does electronegativity change actually? Electronegativity increases from left to right. So chlorine has highest and sodium has least according to this. Okay. So highest of the 7 elements, L is actually chlorine and M is actually sodium. Now element L contains covalent bonds. Element L, chlorine does exist as Cl2, so I agree, one is correct. Next, element L has a higher atomic number than element M. Yes, of course, because chlorine is to the right of sodium, so it has higher proton number, true atomic number. A compound of L and M, NaCl, sodium chloride, has ionic bonds, correct. So I'm going to go with all three, yes. Next, 5. Ammonia reacts with acids to form the ammonium ion. Which one is correct? Shape of NH4 plus. So ammonia, although it is pyramidal and 107 degrees, after it forms a dative covalent bond with H plus, it actually turns into a tetrahedral structure, which has an angle of 109.5 degrees. Okay, but if it was ammonia, the answer would have been A. Number 6. Electronegativity differences can be used to help determine the oxidation number of an atom in different species. A number of rules are used which include: the more electronegative atom is given a negative oxidation number, hydrogen is more electronegative than group 1 metals, and oxygen is more electronegative than hydrogen. Which row is correct? Okay, disproportionation and redox. Let's see. So, check this. Chromium over here. So, oxygen is always -2 except peroxide. It's -8 here, and chromium is +6. And here, chromium, this should be -14, and chromium should be +6 times 2, which is +12. So it's still +6. As a result, A is not a redox reaction because chromium maintains its oxidation number of +6. Next one. Sodium hydride. Hydrogen is more electronegative than group 1 metals. In metal hydrides, hydrogen has an electro oxidation number of -1. Sodium is +1. And sodium is still +1 over here. So, as you can see, hydrogen changes from -1 to 0. So in fact, yes, hydrogen is oxidized from -1 to 0. So yes, it is a redox reaction. So 6B is looking good. However, is it disproportionation though? Look, here the H2O in water. What about it? Let's just go through this. Sodium is +1, it remains as +1, nothing happens to sodium. Oxygen is -2, it still remains as -2 over here. And this hydrogen over here, it is +1. And the hydrogen in water is also +1, and there are two of these. So one hydrogen actually remains as +1, the one in hydroxide, and another hydrogen actually goes from +1 to 0. Okay, and one hydrogen over here goes from -1 to 0. So it is looking like a disproportionation reaction. Let's look at C though. Let's look at C. I'll come back to B soon. I'll come back to C. So in C, what do we have? Hydrogen is +1. Here, manganese, right? If you look at this, oxygen is -8, the four of them. So this manganese over here, it must be +6. Now this one changes from, this is -4, so this is +4. This is -8, so the manganese must be +7. So that manganese atom on the left actually changes from +6 to +4 as well as +6 to +7. So yes, this is redox as well as disproportionation. C is correct. Now, yeah, we can take a look at part B again, the B, 1 and B. NaH plus H2O changes into NaOH and H2. This is rather different, okay? Because, check this. Here, sodium is +1, also +1 over here. Oxygen is -2, also -2 over here. Look at the hydrogens. Hydrogen is +1 here, 0 here, -1 here, and +1 here. So what happened is one of the +1 hydrogens over here remained as +1, but one of them went to 0, and here one -1 went to 0. So this type of reaction is not exactly classified as disproportionation. Okay, disproportionation is one where the same species gets oxidized and reduced simultaneously. Like the same species, like manganese over here, it goes from +6 to +4 as well as +7, not the other way around. That is not classified as a disproportionation reaction, which is why B is wrong. Could I clarify? So that's that. Next, which assumptions are made about ideal gases? Ideal gases contain molecules with no mass. They have negligible volume, okay? But this is wrong. One is wrong. So one is wrong, the answer must be D. Because we said that they have negligible volume, but not no mass. And they have no IMF, okay? So yeah, 7 is D. 8. A 200 cm cube sample of water has an amount of oxygen gas dissolved in it. The amount of oxygen gas has a volume of 6 cm cube when measured at 1 into 10 power 5 pascals and 35 degrees Celsius. What is the concentration of oxygen gas in the water? It behaves as an ideal gas. So I guess we can use PV is equal to nRT to do this math. So the pressure is 1 into 10 to the power 5. The volume is 6 cm cube, which is 6 into 10 power minus 6 meter cube, is equal to nRT. So N times R, the value of R is 8.31, and temperature is actually 35 plus 273 Kelvin. You need to convert to Kelvin, right? Okay, so 1 into 10 power 5 times 6 into 10 to the power minus 6 divided by 8.31 divided by 35 plus 273, that gives you an answer of N is equal to, 2.34 into 10 power minus 4 moles. Now we need to convert it into concentration, so that's moles by volume. So 2.34 into 10 power minus 4 divided by, it's in dm cube, right? So it's 200 divided by 1000. So divided by 200 by 1000, which gives you an answer of 1.172 into 10 to the power minus 3. Good. So our closest answer is actually A to B. That's good. Next 9. Which statement explains why buckyball, Buckminster fullerene, has a lower melting point than graphite? Okay, so buckyball, remember the buckyball is actually a simple molecular structure, C60, right? 60 carbon molecules only. Buckyball exists as discrete molecules with weak intermolecular bonding. This is 100% correct. They are discrete molecules. It is not a giant structure. Graphite is not partially ionic. Okay, it's wrong. It's a covalent structure, but giant. The carbon-carbon bonds in Buckminster fullerene are shorter and more strained. If it's shorter, it would have stronger melting point, higher melting point. The mobile electrons does not make graphite have a metallic structure. I remember this clearly because I actually made a mistake back in my AS, which is why I missed my country highest marks. I did not know that buckyball was actually a simple molecular structure, so make sure you don't repeat that. I actually got 38, I think, out of 40 in AS Chemistry Paper 1. So this was one of the mistakes. The other, I don't know really. Next, number 10. Which equation represents the reaction whose standard enthalpy change is the standard enthalpy change of formation of water? So we need to form water, and we can only have 1 mole of water, okay? And the other elements have to be in their standard states and conditions. So clearly the answer is 10B. These are wrong because they're in ion form, and this is wrong because they're in atom form. We know that hydrogen and oxygen exist as diatomic molecules. Which mixture will react to form exactly 1 mole of water? Okay, so H2SO4 plus NaOH forms Na2SO4 sodium sulfate plus H2 acid plus base is equal to salt plus water. To balance this, we need 2 moles of this, and to balance this over here, we need 2 of this. Okay. Now I need 1 mole of water. So let's try with part 1. Volume in cm cube of 2 mole per dm cube. Okay. So 250 cm cube into 2. Let's try this. 2 mole per dm. 250 by 1000 into 2. That's 0.5 moles. And for sodium hydroxide, that is 500 by 1000 into 1, which is 0.5 moles. Okay, so NaOH is actually the limiting factor over here. NaOH is the limiting factor because we have 0.5 mole of H2SO4. We needed 1 mole of NaOH, but we have 0.5, so we need to work with this. As a result, only 0.25 mole of H2SO4 will react, and we will get 0.25 moles of Na2SO4 and zero point 0.5 moles of H2O. Okay, because they have the same molar ratio, and since it's the limiting reagent, we need to work with the limiting reagent. So yeah, A is wrong. Now let's try B. So for B, it's the same for H2SO4, but the moles of NaOH has changed. It is going to be 1000, right? 1000 by 1000 into 1, so that's 1 mole. We have 1 mole of this, and that's fine now, it's perfect. We needed 1 mole of NaOH to react with 0.5 mole of H2SO4 according to molar ratio. And yeah, now we will get 0.5 mole of the salt and 1 mole of the water molecule. So our answer is B. 11B is correct. Anyway, guys, do comment below if you have any queries still. And what are you guys interested in? What are your hobbies? I never asked before. About myself, I like playing video games a lot. I like watching anime. I like manga. I'm a huge One Piece fan. For games that I've played recently, I recently finished Spider-Man 2 on my PS5 and played the God of War Valhalla DLC. That was amazing. Just finished it today. But I haven't been getting too much time, I haven't been able to play much games or watch some anime. I've been busy with New Year and stuff. I'm actually going to watch a Coldplay concert next month in Thailand. I'll be going there, so that's gonna be fun. But yeah, I'll try to launch as many videos as I can for you guys because this is obviously the priority. I'll be free after April because I'll be stopping tutoring in Bangladesh over here, so I can focus on med school and YouTube as a whole. So let's see how it goes. Number 12. The enthalpy change for neutralization of nitric acid with NaOH is minus 57 kilojoules per mole. In an experiment, 20 cm cube of 4 mole per dm cube HNO3 is mixed with 30 cm cube of 2 mole per dm cube NaOH in an insulated container. The initial temperature of both solutions is 25 degrees Celsius. It can be assumed that the heat capacity of the product mixture is 4.2 joules per cm cube per degree Celsius and that there are no heat losses. Okay, so let's do this. HNO3, right? HNO3 plus NaOH, monobasic and monoestic. So they react together to form sodium nitrate soluble salt plus water. So let's do this. For HNO3, right? The moles, that is 20 by 1000 times 4. 20 by 1000 times 4, which is 0.08 moles. And for NaOH, that is 30 by 1000 times 2. 30 by 1000 times 2, which is 0.06. So always remember, you will go with the limiting reagent. So we have to use NaOH over here. Okay, we are going to use NaOH. So this doesn't matter. Yeah, now since I know that 1 mole releases minus 57 kilojoules of heat, so what about 0.06 moles? How much will it release? Minus 57 times 0.06 times 57, which gives an answer of 3.42 kilojoules. Okay, now let's work it out. We know that H is equal to mc del theta, so the total heat released is 3420 joules. I convert to joules equals to the mass. So the mass is very tricky. You actually need to consider the net mass, which is 50 cm cube. 50 cm cube, the volume. Then C is 4.2 and del theta. We are going to find out the del theta. So 3420 divided by 50 divided by 4.2 gives us a value of del theta equals to 16.3 degrees Celsius. So since heat was released, obviously exothermic, so the final temperature will be 16.3 plus 25, which gives you an answer of 41.3 degrees Celsius. Very interesting sum. 12 is A. I've never seen this before. This is the first time that CI has given this, but food for thought. Please go through this properly. Some bond energies are listed. 1 mole of hydrogen reacts with water with oxygen to give water vapor. Using the bond energy data, what is the value for the enthalpy change of this reaction? Okay. So 1 mole of hydrogen gas reacts with oxygen to give water vapor. Okay. So what have we broken? 1 mole of hydrogen bonds, which is plus 436. Half moles of oxygen, which is plus 496 by 2. All right. And for bonds that have been made, 2 bonds of OH, which is minus 463 times 2, since there are 2 OH bonds. So let's just add this up. 436 plus 496 by 2 minus 463 times 2, which gives us a value of minus 242. Minus 242 kilojoule per mole, minus 242. So do we have that? Yes, we do. 13 is C. 14. Which particle contains nitrogen in the same oxidation state as this ion? So this is this what is this exactly? N2O2. Is it a peroxide ion? So what is peroxide or superoxide basically? Where oxygen has oxidation number other than minus 2. Okay, you guys need to know that. So I'll tell you the name of this compound exactly. Just give me one sec. I'll confirm. N2O2 ion. So the name of this compound is diazine diolate. Diazine diolate. Okay, so since it is not mentioned that it's peroxide or something, we should assume that oxygen should have an oxidation number of minus 2. So minus 2 times 2 is minus 4. So these nitrogens should have a total oxidation number of plus 2. So each nitrogen is plus 1. So we are looking for plus 1 over here from nitrogen. So let's look. Fluorine is always minus 1. Hydrogen is always plus 2, plus 1, plus 1, plus 2. And nitrogen is minus 1 over here. So A is wrong. Here, 4 times minus 2 is minus 8. Each nitrogen should have plus 4 to balance this. Wrong. Here, nitrate. Minus 6, nitrogen should be plus 5. Wrong. This one. Fluorine is minus 2. Hydrogen is plus 1. Nitrogen has to be plus 1. So yes, we have our answer, 14D. 15. Sulfur dioxide reacts with oxygen as shown. Which change will move the equilibrium position to the right hand side and change the value of the equilibrium constant? So listen, only changing temperature changes value of Kc. So the answer is already fixed. Decreasing the temperature of the reaction. Because it's an exothermic reaction, yes, decreasing temp will move it to the right hand side. And only temperature affects Kc. Okay? Nothing else. Remember that. 16. Solutions X and Y both have concentration 0.1 mole per dm cube. Fixed volume of solution X is added to a conical flask, and solution Y is added from a burette to the conical flask. A titration is performed. The diagram shows the pH titration curve for the acid-base reaction between the solutions. What are solutions X and Y? Okay, so X is something that is alkaline. X is something that is alkaline, and it can't be potassium hydroxide, because if it was potassium hydroxide firstly, then the curve would have started from 14 and it would be horizontal like this. It would not have the buffering capacity. This thing you'll learn in A2 when you learn about buffers. When you see a curved section like this thing is called the buffering capacity of the weak base. Okay, so clearly it is not as strong. I'll give more explanations in a bit. So it can be potassium hydroxide, it has to be ammonia. And on the other hand, do you see this? Look where it ends. Look where the acid ends. Around minus 1. Okay, so that is the idea for a strong acid. So the answer is A. Because look at this. Do you see the buffering capacity over here, like here? Not really, right? It is more or less horizontal, right? So if both of them were strong, then it would have started like this, maybe 14 and 13. It would have been horizontal at the top, then it would go like this, and then it would go like this. It would end at something like -1, like here. Okay, this is what would have been different. This is what would have been different. It would be like this. Understood? And if it was a weak acid instead, then it would actually go from here. Look, where does it change? Around 9, right? So 7 minus 2 is 5. Then it would have been something like this. If it was a weak acid, it would have the buffering capacity effect, kind of like this. It would end like this at somewhere like 2 or 3 if it was a weak acid like ethanoic acid. Okay, so you need to know the 4 types of graphs, and if you're looking for notes, all of those are available, on my Patreon. So you can consider supporting me there. In the second tier, it's $20 monthly. So yeah, you can get those notes if you do support me. So you can check those out. I'll add a link in the description. Anyway, let's move on to the next part, number 17. Which row shows the expected properties of the element astatine when compared to iodine? So if you take a look at the periodic table, as you go down the periodic table, electronegativity actually decreases. So iodine should have more electronegativity compared to astatine, and astatine should have less electronegativity. Next, volatility. As you go down the group, they become less volatile. So it should also be less volatile because the electron number increases, so more ID forces, and so more stable. Okay. 18. The rate of an exothermic reaction is followed by measuring the concentration of a reactant at regular time intervals. During the experiment, the temperature of the reaction mixture is not controlled. Which graph shows the change in concentration of reactant against time? Concentration of reactant against time. Okay. So concentration of reactant will obviously decrease. It can't increase. So D is clearly wrong. It's between A, B, and C. So it's an exothermic reaction, right? So an exothermic reaction actually does what? It releases heat. So over time, heat will be released, and as heat released increases, temperature increases, and rate will increase over time. So the graph should go like this. Initially, it should have slow rate. In the middle, it should speed up. The gradient should be higher because the temperature is increased, and at the end, the rate should also decrease. It will decrease a bit because even though temperature is high, the number of reactants has decreased, so chance of successful collisions is also chance decreases. A is wrong because it shows a constant rate. B is correct. It is correct because look, initially rate is alright, okay. At this point, temperature increases, right? So the rate of collisions also increases. It becomes steeper, and then at the end, it flattens out because basically um, the uh, reactant is used up, so there are less chances of successful collisions. Okay. Next, 19. I actually have this done for some reason. For a particular reversible reaction, the backward reaction is endothermic. The activation energy of the backward reaction is 160 kilojoule per mole. So you need a diagrammatic representation for this. Check this out. So uh, suppose A plus B combines to form C. Since the backward reaction is exo, the forward reaction must be endothermic. Okay. Sorry, the backward reaction is endothermic. Backward reaction is endo, so the forward reaction must be exo. So check this out. A and B combine to form C. The backward reaction is endothermic. Backward reaction is endothermic, and the activation energy of the backward reaction is uh, 160. So this blue arrow that you see over here, the activation energy from C to the top of the peak is plus 160, and C to A plus B, the backward reaction, is an endothermic reaction which has plus del H. So let's match A. The activation energy of the forward reaction is equal to minus 160. No, 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 no. Clearly, the activation energy of the forward reaction is this green arrow over here that I just drew. It must be less than 160. And activation energy is never negative. That's the wrong part over here, okay? So, yeah, A is wrong. Next, B. The activation energy of the forward reaction is 0 kilojoule The activation energy of the forward reaction is 0 kilojoule per mole, but less than 160. It should be more than, it should not be 0. It can be assumed that the backward reaction proceeds by a mechanism that is the exact reverse of the mechanism of the forward reaction. The activation energy of the forward reaction is more than 0 kilojoule per mole, but less than 160. Yes, I agree. Because this green arrow, you know, it must be smaller than 160, but yeah, at least 0 kilojoule per mole, which is why B is the correct answer. I'll show you why C and D are wrong. The activation energy of the forward reaction is equal to plus 160, impossible. The activation of the forward reaction is greater than plus 60, which is also impossible because the backward reaction is endothermic. As a result, the activation energy of the forward reaction must be less than the activation energy of the backward reaction, as you can see in the diagram. So for our questions like these, always draw a diagram first, okay? 20. HCN has been detected in interstellar gas. The molecules below have also been detected in interstellar gas. Which molecule contains the same total number of valence shell electrons as HCN? Okay, let's talk about HCN. So HCN, cyanide, right? If you think about the CN ion, what is it basically? So if I draw the dot and cross, it's something like this. Carbon has 4 electrons, right? Nitrogen has 5. Nitrogen has 5. So it's kind of like this. 1, 2, 3. So carbon is 8 in total, right? So the cyanide ion is kind of like this. There is an extra electron from an outer source. As a result, cyanide has a charge of -1. On the other hand, hydrogen has a charge of +1. So that's how we get HCN. So see if you guys get it. This is really important. This is really important. Okay, let me show it in another way. Wait. Suppose I have H over here, C over here, and N over here. So hydrogen gives 1 electron like this, and carbon also gives 1 like this. So that is the single bond between HC. I drew the cyanide ion, by the way, before, like something potassium or something. So this is what happens. Now, what about the rest? So carbon has, you know, 4 electrons in total. So it will give the other 3 over here. 1, 2, 3. And, nitrogen on the other hand has 5. So what will it do? It basically gives, how many does carbon need? It needs 1, 2, 3, 4, 5, 6, 7, 3 more. So nitrogen also gives 3 like this. So that's it for, carbon. And what about nitrogen though? How many does it have now? 1 over here, 2 over here. So nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 in total. So this is how HCN is planned out. Now, if you think about the cyanide ion, what will happen is if it dissociates, the Cn ion actually takes 1 electron away from hydrogen. Okay, the Cn electron actually takes 1 away from hydrogen and it turns into H plus, and this turns into Cn minus basically. Okay, now um, which molecule contains the same total number of valence electrons as HCN? So how many does HCN have? We're talking about valence electrons. So let's take a look at this carefully. So let's start with an easy option like NH3. So for example, NH3, 1, 2, 3, 4, 5, hydrogen, 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 hydrogen. Outer shell electrons, okay. So 1, 2, 3. So outer shell electrons for ammonia is, 1, 2, 3, 4, 5, 6, 7, 8. For ammonia, it is just 8. Then for NO, let's talk about NO. NO. Let's check NO. How will it be like? Basically nitrogen monoxide, right? Um, okay. So nitrogen monoxide actually has a double bond in between it. So it's kind of like 1, 2, and oxygen will also give 2 over here. So in total, oxygen has 6 electrons. So 1, 2, 3, 4, 5, 6. So how many is that? 8. And nitrogen, on the other hand, has 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5, 6, 7. So this is the structure of nitrogen monoxide. So how many valence electrons is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 for NO. And for PN, let's do PN now. PN. So I think we don't need to make it so complicated. We can just count the number of electrons like this. Check this. For HCN, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm looking for 10 essentially. So B and C are wrong. Let's talk about P and N. Nitrogen has 5 in its outer shell. P also has 5. So 5 plus 5 is 10. I think that's how it's done, right? And in HNO, HNO is a bit complicated. HNO, it will be 6, 5, and 1. So that's 12. Okay, so that's how it was supposed to be done. HCN was supposed to be like this, 5, 4, 1, which is 9 plus 1, 10. That matches with PN. Sorry for making this complicated. That was the easy process. I tried to break it down too much. Anyway, moving on to 21. The diagram shows the Boltzmann distribution of energy of gaseous molecules at a particular temp. Which statement is correct? So if the temperature of the gas is raised, the height of the maximum curve increases. Wrong. If temperature is raised, the graph actually shifts like this, so height decreases. If temperature of the gas is raised, the maximum of the curve moves to the right. Yes, 21B is correct. It does move to the right and height decreases. 22. The elements magnesium and phosphorus are reacted separately with an excess of oxygen to form the oxides. Each oxide is then added separately to water and the pH values of the resulting solutions are measured. The same two elements are reacted separately with an excess of chlorine to form the chlorides. Each chloride is then added separately to water and the pH values of the resulting solutions are measured. Which row is correct? Oxide giving higher pH. So magnesium hydroxide and phosphorus. So basically magnesium hydroxide is basic in nature, while oxides of phosphorus are acidic. In fact, they'll give phosphoric acid. So higher pH, the more alkaline one is obviously magnesium, and chloride giving higher pH. So magnesium chloride, if it actually dissolves in water to give pH like around 6.5, and PCl3 or PCl5, they actually react in water to give a much more acidic solution. Okay, they give a much more acidic solution. So yeah, clearly both of them are acidic, but 6.5 is higher than 3 or 2, the one created by phosphorus chlorides. So both of them will be magnesium. 23. Equal volumes of saturated solutions of magnesium hydroxide, calcium hydroxide, and strontium hydroxide are completely neutralized with dilute sulfuric acid. The water is gently evaporated from each of the resulting solutions, leaving the corresponding solid sulfates. 3 solid sulfates are completely dissolved in minimum volume of water required to produce the saturated solution. Which statement about the volumes of water needed to dissolve the sulfates is correct? Okay. So basically, what happens for sulfates down the group? Mg, Ca, Sr, Ba. For sulfates, solubility actually decreases down the group. Okay. So the most soluble here is magnesium sulfate. So it will require the least volume of water. So B is wrong. On the other hand, barium will require the most. In fact, it is insoluble. So calcium sulfate will not require the greatest. In fact, it is strontium because it is the least soluble, right? That is why it requires the most volume of water. 24. Which statement about halogens is correct? Iodine cannot behave as an oxidizing agent. Wrong. All halogens are oxidizing agents. The volatility of the elements increases from chlorine to iodine. Wrong. Volatility decreases from chlorine to iodine. Next, when an equimolar mixture of chlorine and hydrogen is exploded, only one product is formed. Yes, we only get HCl, that is the only product. C is correct. Good question. When concentrated sulfuric acid is added to solid sodium bromide, bromine gas is produced along with a number of other products. However, when concentrated sulfuric acid is added to solid sodium chloride, only hydrogen chloride and sodium hydrogen sulfate are produced. Why? So you can answer this in many ways. You guys can say that either chlorine is a stronger oxidizing agent than sulfuric acid, or chlorine is a stronger oxidizing agent than bromine, or you could word it this way: bromide is a stronger reducing agent than chloride. That also works. Okay, so this has nothing to do with volatility, nothing to do with acidity. And C is wrong because sulfuric acid is an oxidizing agent, but it is stronger than bromine, not chlorine. Okay, as a result, the answer is D. The bromide ion is a stronger reducing agent than chloride, the one I was telling you guys. So the ones I told you, all of these could be present. Bromide stronger reducing agent than chloride, chlorine stronger oxidizing agent than sulfuric acid or bromine, etc. Which statement about the oxides of nitrogen is correct? During lightning storms, atmospheric oxygen and nitrogen combine to form oxides of nitrogen. O2 plus N2 combine to form NO during lightning storms. This is 100% true. This also occurs in exhaust fumes. Do you want to go through the other ones? In a catalytic converter, nitrogen monoxide is removed by reaction with carbon dioxide. No, no. It's NO2 plus CO2 to form, you know, it's not nitrogen monoxide, okay? We get nitrogen instead. It's NO2 plus CO, right? Next one. And what do we get? Unburnt hydrocarbons, right? They are, completely combustion. So in the major reaction in, the catalytic converter is conversion of CO and CO to carbon dioxide and nitrogen monoxide or nitrogen oxides to, nitrogen dioxide. Okay, that's the logic. In car engines, the restricted supply of oxygen elements. No. We still get nitrogen oxides. In the atmosphere, nitrogen monoxide reacts with sulfur dioxide. No. It's like this. NO2 reacts with SO2 to form NO plus SO3. Nitrogen dioxide reacts with sulfur dioxide. Okay. 27. Structural isomerism and stereoisomerism should be considered while answering this question. Okay. We start with organic then. 2-bromopentane is heated with an excess of ethanolic sodium hydroxide. 2-bromopentane. So CH3, CHBr, CH2, CH2, CH3. This is 2-bromopentane. Now, ethanolic NaOH, it will actually cause an elimination reaction. So, in one route, we get CH2 on the left side, basically CH, CH2, CH2, CH3, no cis trans isomerism, and on the other side, we get CH3, CH, CH, CH2, CH3. So as you can see, the left one has no cis trans isomerism, while the one on the right, that is pent2-ene. Pent1-ene does not have cis trans. Pent2-ene has cis trans isomerism. So we actually get in total 3 products, right? 1 over here and 2 over here. Which compound is a secondary alcohol that can be dehydrated to form an alkene with MR70? This is a tertiary alcohol. This is gone. So it's written BCD. So let's try this. If we dehydrate this, okay, we are going to get this compound maybe, okay. So that is CH3, C, CH3, and over here we have C, CH3H. So let's count 1, 2, 3, 4, 5. 5 times 12 is 16. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 10, which is 70. Why is my luck so great today? The answer is B. I didn't need to check the rest. Just check if you look at this one, maybe this over here. CH3, CH2, CH, CH2, that is 4 times 12, 48, plus 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, plus 8, which is 56. That is below 70, right? So that's B. 29. The conversion of propan 1-ol into propan 2-ol can be completed in a two-stage synthesis. The first stage is to heat the propan 1-ol with concentrated sulfuric acid. Okay. So CH3, CH2, CH2OH. We heat it with concentrated sulfuric acid. Okay. And we want to convert it to propan 2-ol. So afterwards, it will be dehydrated to form CH3, CH, CH2. We get propene. Now, I want to convert it to propan 2-ol, which is CH3, CHOH, CH3. How to convert to propan 2-ol? By, hydration, which is done using steam with phosphoric acid. So that is C. Which type of reaction happens during the hydrolysis of 2-bromopropane? Hydrolysis of 2-bromopropane, 3CH3, CHBr, CH3. Hydrolysis reaction, right? We get CH3, CHOH, CH3. We need sodium hydroxide aqueous, and this type of reaction is nucleophilic substitution reaction. Okay. Electrophilic addition for alkenes, free radical substitution for UV light and halogens, any alkane or something works. And nucleophilic addition for carbonyl particularly. 31. The organic ones seem pretty easy for this variant compared to the other ones. A mixture of ethane and an excess of chlorine is exposed to UV light. How many different products, each containing only 2 carbon atoms and at least 1 chlorine atom per molecule, can be formed? Ethane, CH3, CH3. Exposed to chlorine and UV. How many different products, each containing only 2 carbon atoms and at least 1 chlorine atom per molecule, can be formed? Okay, let's try. So one is CH2Cl CH3. Then we can get Cl2 CH3. Then we can get Cl3C CH3. This is one variant. Okay, we got 3 over here. Next, we can get some like this Cl CH2 CH2 Cl, one on each side. Then we can also get like 2 on one side, CH2Cl, but 1 on the other. Then we can get 2 on both sides, Cl2 CHCl2. Then we can get 3 on one side, 3 on one side, and 2 on the other, or 3 on one side and 3 on the other as well, or 3 on one side and 1 on the other. So let's check all the combinations. So firstly, CH3 normal on the other side, then 1, 2, 3 on the other. And here we have 1 on each side, 2 on each side, 3 on each side. Then the other combinations. Uh, 1 on each side, 2 on each side, 3 on each side. Then we have 2 on one side, 1 on the other, 2 on one side, 3 on the other, 3 on one side, and 1 on the other. These are all the combinations, right? 3, 2, 3, 1. Then I'll check. Wait. We did 1, 0, 2, 0, 3, 0. There. Then we did 1, 1, 2, 2, 3, 3. Then we did 3, 1. Right? We did 3, 1. We did 3, 2. Yeah, that is all of them. This is 1, 1. We did 2, 2. We did 3, 3. Then this is 3, 2. This is 3, 1. And yeah, 2, 1. So in total, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. According to this, 9. So yeah, 31 should be B. 32. When 1-methylcyclohexene reacts with bromine, the product is X. When 1-methylcyclohexene reacts with HBr, the made product is Y. Okay. So let's try to do this. X will be like this because it doesn't matter where it's attached. We get the same product. So one bromine over here, one bromine over here. Done. And for Y, what do we get? The major product. Remember that Br will be attached to the carbon which has more alkyl groups, which is this one particularly. So if I draw Y, it will be something like this. So the bromine will get attached here and the hydrogen will attach here. Now X is a mixture of two stereoisomers. Y does not have stereoisomers. Wrong. Look at this. Check this. This compound, this carbon over here is chiral, so Y does have stereoisomers. B. X is a mixture of two stereoisomers. Y is a mixture of four stereoisomers. Wrong. Y only has one chiral carbon, so it is a mixture of two. Uh, but hear me out. There is one issue though that I have not addressed, which is, if you look clearly, basically X has two chiral carbons over here. X has two chiral carbons. Now, that is why X is a mixture of two stereoisomers is wrong in the first place. It should have been 4, so it's basically between C and D. Now, between C and D, it says that Y does not have stereoisomerism or stereoisomers, and Y is a mixture of 4 stereoisomers. So, what's the issue here actually? If you think about it, mm, Y can't have 4 stereoisomers, okay? Because there is only one chiral carbon. But if you look at it that way, is it actually chiral? Careful, I think I made a mistake. I'm sorry for this. It is not actually chiral because let's take a look at the diagram again. Look, it is symmetrical. Look, the bromine is added here. So as you can see, why is this chiral but not this? My bad, sorry for overlooking this. If you go to the right and if you go to the left, same compound, CH2, CH2. If you go down, same, CH2, CH2. If you come here, same thing. It is symmetrical about that point. That is why it is not a chiral carbon. It has no stereoisomers. On the other hand, check this. If you go to the right, you have CH2. If you go to the left, you have CHBr, which is what makes it unique. That is why both of these carbons are chiral. But on the other hand, it has no chiral carbons for Y. Okay, so yes, the answer is C. It was a bit tricky, yeah? Next, 33. I have already done this. T is an organic compound which contains 66.7% by mass of carbon. T also contains one atom of oxygen per molecule. It reacts with alkaline iodine to produce a yellow PPT. Yes, so it's a methyl ketone. So let's take a look at A. Methyl propan 2-ol. Methyl propan 2-ol. What is T? So propan 2-ol. What is propan 2-ol? CH3, COH, CH3. So since it's methyl, the methyl group must be here. This is methyl propan 2-ol. So it's a tertiary alcohol which cannot be oxidized. So it cannot give a positive iodoform test. Wrong. Next, go for butanol. Butanol can also not give a positive iodoform test. Who can give positive iodoform tests? Ethanol, ethanol, then some secondary alcohols with a methyl group as a side chain, and all methyl ketones. So let's take a look at B, butan 2-ol. Butan 2-ol can give a positive iodoform test. And if you look at butanone, it can also give a positive iodoform test. But if you do the math for butanone, the percentage mass by carbon, 4 times 12 divided by 4 times 12 plus 8 plus 16 is 66.67. But for butan 2-ol, it isn't. Try it. 4 times 12 divided by 48 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 16. Try doing it. 48 plus 10 plus 16 and above 48 by answer into 100. It is actually 64.86%. So yeah, B is wrong as well. So it's D. 34. Which statement about butanone is correct? Butanone can be dehydrated by concentrated sulfuric acid to give this. No. Ketones typically no. Butanone gives a positive reagent with tolerance. Wrong. Tolerance is a test for aldehydes. This is a ketone. Butanone reacts with HCN by electrophilic addition. No, it's nucleophilic addition. The answer must be D. Butanone reacts with NaBH4 to give a chiral product. Butanone, CH3, CO, CH2, CH3. Reduction by NaBH4, CH3, CH, OH, CH2, CH3. Yes, this is chiral. 35. Methyl butene reacts with HBr at room temperature to produce X as a major product. Methyl butene. So butene, CH3, CH, CH, CH3. This is butene. So methyl butene must have a carbon, must have a methyl group on the second carbon, or else it wouldn't be called that. Wait, let me draw it again. So it's like this. Methyl butene. 1, 2, 3, 4. And yeah, it's 2 methyl butene, basically. Methyl butene, same thing. So it reacts with HBr. So HBr reaction, carbon, the bromine will be attached to the carbon with more alkyl groups. So this is the product. This is X. Now compound X reacts with KCN in ethanol to produce compound Y. So I'll draw it again. The compound is like this: CH3, C, CH3Br. We have CH2, CH3. This is the compound. Now this reacts with KCN in ethanol. So that's a nucleophilic substitution reaction. CH3C, CH3, CH2, CH3. We get a CN over here, compound Y. Next, compound Y is hydrolyzed with acid to form compound Z. Okay, so we hydrolyze with acid, acetic hydrolysis. So that is CH3C, CH3. This turns into COOH. The nitrile turns into carboxylic acid after following hydrolysis, basically. So this is the compound. So what is this compound? Mainly, it's a very long one. Okay, so this is carbon 1 priority, 2, 3, 4. So this is the main chain. This is actually butanoic acid, and there are two methyl groups on the second one. So it's 2, 2 dimethyl butanoic acid, actually 2, 2 dimethyl butanoic acid. I'm going to go with 35A. Yeah. Okay. Compound Q can be hydrolyzed by itself. The two products of hydrolysis have the same empirical formula. Okay. So it's an ester which can be hydrolyzed. If you break it down here, you get ethanoic acid over here, and which is CH3COOH, and on the right you get propanol, CH3CH2CH2OH. So let's look at empirical formulas. Clearly this isn't it, I think. C2H4O2. This is C3H1234567 H8. Oh, clearly no, this is not it. A is wrong. Let's go for B. I cut it over here. So ethanoic acid on the left, CH3COH, which is C2H4O2 or CH2O. On the right we have 1, 2, 3. Oh, okay, interesting. So alcohol on the left, but carboxylic acid on the right. The compound is like this: OH. Then we have CH2, CH2, COOH. So if you break this down, that is actually C3, O3, hydrogen 1, 2, 3, 4, 5, 6, H6. So that's COH2. Yeah, CH2. These two actually match. So yeah, 36 is B. The tricky part here was, aside from the ester, the alcohol component over here already has a carboxylic acid on the right hand side. Last four, 37. An unsaturated carboxylic acid reacts with alcohol X to form an ester. The structure of the ester is shown. Which geometrical isomer is known in this ester, and to which class of alcohol does X belong? Okay, so this is clearly the cis isomer because the both heavy chains are on the same side. So this is cis. And class of alcohol. Okay, so if you break this down, the alcohol will be like this. So it's propan 2-ol. Clearly, it is a secondary alcohol, yeah, because it is attached to a carbon with two alkyl groups. 38. Which two-step process, I broke it down here, right? As you can see the ester bond. Which two-step process converts cyclohexanol into cyclohexane 1,2-diol? Okay, heat strongly with Al2O3, that will dehydrate it. Now, if you add KMnO4, cold dilute KMnO4, acidified, then yeah, you get a diol. So yeah, 38A is looking good. At first, we dehydrate it to form this alkene, and then after cold dilute KMnO4, you actually get the diol. Okay, so A makes sense. 39. In polymer G, every carbon atom in the polymer chain is bound to one hydrogen atom and one methyl group. Which alkene could be polymerized to make polymer G? Butanone. Okay, so butanone is like this: CH2, CH, CH2, CH3. If you polymerize this, you actually get CHH, CH, CH2, CH3. This is the repeat unit. It is not connected to a methyl group. Okay, so let's try butene now. This is an ethyl group. Butene, CH3, CH, CH, CH3. If you do the polymerization, it will look like this. One hydrogen over here, one methyl group over here. One hydrogen here, one methyl group over here. That fits our criteria. So yeah, 39 should be B. One hydrogen atom, one methyl group. Last, 40. The mass spectrum of compound X has M, M plus 1 and M plus 2 peaks. Okay, so M plus 2 peaks, that means clearly there is a halogen. Other peaks are also present. Peak M is the molecular ion peak M plus. Peak M has relative abundance 15 times that of peak M plus 1. Peaks M and M plus 2 are of equal height. So when M and M plus 2 are of equal height, that signifies that bromine is present. Okay, this signifies that M plus 2 signifies chlorine or bromine halogens, and if they are of equal height, it is bromine. If it is a 1:3, 1:3 ratio, it's chlorine. So we have bromine. It's not chlorine. That is out of the equation. It is bromine. Now we need to do a math. Okay, we need to do a math. So this was actually added. So this was actually added to the syllabus. Let me show you. This was actually part of A2 initially, but now they've moved it to the analysis part of AS. So this is new from 2022 onwards for you guys. Let me show you here. So this formula over here, this was part of A2. It actually abuses, or takes advantage of the abuse is not the correct term, my bad. It actually exploits the fact that the M plus 1 ion is due to the fact of carbon 13 existing in nature, and its percentage is 1.1% out of the total carbons. So the formula is N is equal to 100 by 1.1 times abundance of M plus 1 ion divided by the abundance of the M plus ion. This is the formula that you guys need. It's new, so yeah, be careful and you need to remember this, okay? So this is for you guys who don't know about this already. So we can find out the number of carbon atoms using this formula. So N equals to 100. So originally it was something like this. If you do the math, M peak, M plus peak divided by M plus 1 peak times N is equal to 100 by 1.1. The 100 corresponds to the total carbon abundance, and 1.1 corresponds to the M plus 1 peak. So let's see the abundance. Yeah, peak M has a relative abundance 15 times that of M plus 1. So peak M has an abundance that is 15 times of M plus 1. Okay, so abundance of M peak is 15 times that of M plus 1 is equal to 100 by 1.1. So N is actually equal to 100 by 1.1 into 1 by 15. So 100 by 1.1 into 1 by 15 gives you an answer of N is equal to 6.06. Okay, so 6 carbon atoms in total. So I have 6 carbon atoms and bromine. So let's do this. 2 bromo, 2 methyl hexane. What is this? CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. 2 bromo, 2 methyl. What does that mean? On the second carbon, right? 2 bromo and 2 methyl. So in total, it has 1, 2, 3, 4, 5, 6, 7. So C is wrong. Let's do the next one. 3 bromo, 2, 2 dimethyl butane. So CH3, CH2, CH2, CH3. This is butane. 3 bromo. Okay, so 1, 2, 3. 3 bromo, 2, 2 dimethyl. So second carbon. CH3, CH3, and this should be H. Okay, so in total, 1, 2, 3, 4, 5, 6, 6 carbon atoms, and we also have bromine. So yes, we have our winner. 40 is D. Good question for you guys. New question. The acid base titration curve was also added from 2022 onwards, so that is also a good question for you guys. So hopefully I helped you guys. That was it for this paper. We don't have any more left. I hope I could help you guys. It was, yeah, relatively easier compared to paper 1-1 or 1-2. However, there were a few tricky questions like the acid base enthalpy one, like 3-4 questions which were very difficult, and the one with the chiral carbon one might be a bit hard. But hopefully, I could help you guys. That was a good paper. So if you like the video, please do remember to subscribe to the channel, and shout out to my top tier patron for the month. We only have one person right now supporting me in the highest tier. It's Dewa, a really nice guy. He's really smart. Hoping he does well. And if you guys want your name featured here, please do consider supporting me on Patreon for a feature at the end screen for every video. Also, I'll link the paper for uh, you know chemistry May-June 2023 paper 1-1 up here, and the paper for May-June 2023 paper 1-2 down here, and the playlist for chemistry P1 up here. And remember to hit the subscribe button. See you guys. Bye bye. Take care.